Hello, this is Jeffrey Fox here, and we're coming to a use case done in detail. The last section involved 51 separate use cases and skimmed them over all of them with about a slide or so each. Here we're going into devoting 2 units to the one case of recommender systems, and in particular the application of Netflix, which was actually done as a summary in the last section. As always, we're using clouds, we're running data analytics. As we saw very amazingly in the physics example with 3,000 people on an experiment, we have to do it collaboratively. And we're processing big data and we're solving problems in X informatics. Here we have our collage of the various areas of informatics defined on the web. And as we noted, this is just a sample of some of the actual areas of X informatics. Not all of them, like physics informatics, doesn't yet exist. And this we might even call commerce informatics, lifestyle informatics. We've used various names for this in the past. In the first short lesson, we'll give an introduction to recommender systems, what they do, and why they effectively adjust an optimization system, and they're solving a problem which is just an optimization problem. So here we start off with a slide of examples, and essentially a lot of commerce activities, where that commerce varies from books through electronics through movies. Those are dominated by recommender systems. At least a lot of their power is. And also just the basic internet site personalization relies on recommender systems, which suggests what things to assign to the page that the person is looking at. And so the obvious example is Amazon, which probably first popularized this by the buy recommendations they have on the web. Um, Other examples are Netflix, which is movies to look at. There are sites that use recommender systems to recommend restaurants to eat at, events to go to, and of course, everything to buy. There are sort of related technologies which use a mixture of user choice and grouping of internet sites together that present customized Google News pages and similar types of uh, websites. In the real world, we have given some sales statistics. We need to decide on discounts at supermarkets and the placement of where placement should be put, where products should be placed next to each other by looking at buying habits and see what correlations there are. LinkedIn uses these technologies to identify possible colleagues at which then you can invite to join you and become one of your collection. Even probably, I mean, equally important example is providing matches between employers and employees, or employees and jobs at sites like Career Builder and Monster. I notice all of these are optimization problems. You're trying to do something in a way that is in some sense optimal. That optimality is not always so easy to measure, but intuitively, these are all optimization problems. Here we have a little diversion. Everything is an optimization problem. When we were doing that Higgs analysis, the discovery of the Higgs boson, we saw how to fit models to data, because we had a background and then we had a little bump, which was the Higgs. That's an optimization problem to fit that model to the data. I say we've already done matching of users to jobs or books, users to books, or in LinkedIn, users to other users. Related optimization problem, classification, where you have a list of categories, which are sometimes called ontologies, and you wish to optimize the assignment of the members of assignment of the data to the ontology. Somewhat further afield, if you're in a jungle with snakes and lions and things around you, keeping alive in that jungle involves optimizing one's position, optimizing one's actions. You don't want to alert the snake that you actually are somebody they could they could strike and things like that. So that's an optimization problem where the optimal thing you're trying to do is to maximize your chance of staying alive. And that's what you're. And when you are doing that, you usually often use your eyes to make decisions. Your eyes are actually looking at pixels and optimizing the interpretation of those pixels based on what you know up to now. So that's multiple optimization problems there. When you look at this on the computer, you end up trying to minimize a function, or sometimes you actually maximize the negative of a function. Um, and often, actually, when we try to solve these problems for the computer, we have to find an ingenious choice of function because converting happiness into a function is not always so easy. Physics has learned to do this. Nature minimizes the free energy. That's the way the basic particles decide what to do. One general approach that is what we've already mentioned, the funny space approach, where you think of people and items as points in the space, and this optimization problem is phrased in this space. And this space is often a very non-traditional space, doesn't have normal distance functions. A lot of the points in the space are funny because some of the coordinates of the points are undefined and so on. But still, everything is an optimization problem. When you vote for the president, you're solving an optimization problem of how to best serve the country over the next few years. Now we just tell you what's going to go on in the rest of this unit, where we're going to make some general comments based on a lot of which is based on this online site, which I strongly recommend, which is some teaching materials associated with a good book in this field. That book is too detailed for this course, because this course is just a broad overview. But still, if you really want to go into more detail, that book and that site are very good. The slides are extremely good slides. We will discuss the Kaggle site, as it's remarkable that you can post problems and have people solve them. In fact, and compete to solve, and therefore you can get some sort of crowdsourcing, getting people to help you and work remotely on the same problem. And then the end of this unit is some comments from Netflix, which came from a 2012 tutorial on their approach as a company. So that's the end of this short introduction. Thank you very much. The next section will talk about a broad introduction to what recommender systems do.